Okay, this topic I'm going to talk to you about is called colligative properties of solutions. Okay, so if we have a heating curve, this is time or energy, and this is temp in degrees Celsius temperature. Let's say we have some water and it is in a solid form, so it's ice. We start to heat it up. All right, so this is pure water. Eventually, we're going to get to a point where it melts. What temperature will that be at in Celsius? 0 degrees Celsius. And we know that the temperature as the substance begins to melt will be in the solid and liquid phase, and it will flatten out and it will not go up at all as long as there is some ice in it, right? As soon as we get fully to liquid, then as we add more heat energy, the temperature will again start to climb. All right. And what temperature will it turn into a gas phase? It will be 100 degrees Celsius, right? And again, it will begin to flatten out. And you're still adding heat energy, but the potential energy is just increasing. The kinetic energy is not, because there is no change in the temperature. Here, let's put this as liquid right here. And then again, we could go higher, as high as we want to, and it'd be gas. All right, so that's for pure water. Now let's say we take some water and instead we add to it some solute. So like salt or sugar or anything that can dissolve into the water. So this is a solution. A homogeneous mixture of two things. Remember, homogeneous means that it's distributed the same throughout at the molecular level. All right, so in this case, when we start heating up a solid solution, so you can dissolve something into water and then freeze it, when it begins to melt, it will do so at a temperature less than 0 degrees Celsius. All right, so you can see that it is, I try to make that a dotted line. Let's see if I can be more successful. Okay, so there we go. So that is melting at a lower temperature. Then, of course, it'll be going up again. Solid, liquid, and it's going to go up and up and up, and it's going to start to boil off. All right, gas. And we'll go over here. It's going to boil at a temperature that is higher than 100 degrees Celsius. All right, so the melting point goes down and the boiling point goes up. The more particles you have in the solution, or how concentrated the solution is, the more this effect will happen. Okay, so let's take a look at the difference between dissolving an ionic compound and dissolving a covalent compound or a molecular compound in water, because there is some differences in how they dissolve. And you've probably seen this before. In fact, you should have seen this before. One of our labs, it's a digital lab that kind of looked at this a little bit. Okay, in this picture right here, which is just a masterpiece of a picture which I drew, it's got a beaker with some water in it, and there's some salt about to go into it and dissolve, right? How many formula units of salt are there in this picture? That when you look up there on the screen, how many are there? How many sodium chloride units are there? 7, that's right. If we were to circle them, I need to actually get this into draw mode. You can see there's, why isn't it doing that? That's really just, oh, there it goes, that goes. For some reason, my pen isn't working. Okay, we're going to use my... So 1. Oh, geez, that's terrible. 2, 3, 4, 5, 6, 7 units, all right? Okay, now, watch what happens when it goes into the solution. As it goes into the solution and it dissolves, the particles all come apart. How many particles do we have in that solution now? 14, right? Okay. Now let's look at a molecular compound. How many units do we have here, or molecules? 7. When that goes in the water, it also dissolves, that all the particles come apart. How many particles do we have in the water? 7, okay? So the number of particles we put into the water with the covalent compounds is the same, but with the other one, it's doubled, right? So which one is going to have this colligative effect property more? The ionic one or the covalent one? Which one has more particles dissolved in the water? Right. So we would still say we put 7 units in. Let's say we put 7 moles into 1 liter of solution. We would say that's a 7 molar solution. So this is a 7 molar solution of sodium chloride. This other one is a 7 molar solution of sugar or sucrose. All right. But the ionic one will have a bigger effect, even though the concentration of the particle, not the particles, but of the compounds is the same. All right, so we say the concentration of the compounds is the same because we started with 7 units and we started with 7 units. All right, but when they're dissolved, the ionic one has twice as much in this case. Some ionics, depending on how many ions are in the compound, will be 3 times as much. All right, calcium chloride has 1 calcium ion and 2 chloride ions for every unit of itself. So that splits up into 3 parts, right? And that would have an even greater effect. Okay, that's it I've got for you. You're going to go and do the gizmos now to explore this, but I just wanted to give you this little preview before you start.